Hello, this is 7th grade, Module 4, Lesson 3. We're going to look at comparing quantities with percent. If each 10 by 10 units, that means these little boxes here, represents one whole, then what percent is represented by the shaded region? So this is 10 by 10, so that's 100, so 100 of these little boxes. So since all of these are colored in, that's 100%. So we're going to say 100%. Now, since I have more, that means it's going to be over 100%. How much more? Well, there's 10, there's 20, there's 25. So it's 100 plus 25. So the total representation here is 125%. All right, so it says in the model above, 25% represents 10 students. So this box right here represents 10 students. How many students does the shaded region represent? So if I say 10 for 25% of the students, and I reduce that down, we'll just make it 2/5. Now, because the whole representation here, the whole model is representing 125%, I'm going to take 2/5 and I'm going to multiply it by 125. All right, and let me show you how to do that on the calculator just to make life a little easier. So 2/5, if I go 2 divided by 5, I wind up with 0.4. Now you leave that on your calculator and then hit times 125%, it's 50. So the question says how many students are represented in the shaded area. We're going to say 50 students. And there you go. All right, let's look at A. I'm going to move this down a little bit here. The members of a club are making friendship bracelets to raise money. Anna and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce over the weekend? All right, so if you remember from the last lesson, we used the setup of is over of equals percent over 100. All right, so they have made 54. Now 54 is your is because that's part. So we're going to say 54. They need to produce 300. There's my total. Now, as you know, the 100 always stays. That never goes away. And clearly it says what percent. So we already know we're solving for the percent there. Now, once it's set up like this, we go ahead and cross multiply. I always do the x first. So 300 times x is going to give me 300x. 54 times 100 is going to give me 5,400. Now I'm going to divide by 300. And these cancel because they become one whole. And if you notice the zero rule here, you can take off 2 sets of zeros because they cancel each other out, leaving me with 54 divided by 3. Now, if you want to use your calculator, you may. 54 divided by 3 gives me 18. So x equals 18 what? What was I solving for? Oh, percent. Don't forget to leave that percent symbol. 18 is a whole number. I need to know percentage number. All right, let's move on to the next one. Clear this up real quick. Anna produced 32 bracelets of the 54 bracelets produced by Emily and Anna over the weekend. Write the number of bracelets that Emily produced as a percent to those that Anna produced. Okay, so we're going to still use our same setup. I always say line equals line, always over 100. It's kind of an easy way to remember it. Now, since Anna produced 32, and of the 54, we need to find out how many that was here. So we have 54. I'm going to subtract that from the 32, and we get 22. All right, so 22. So if she produced 32, then the other girl produced 22. So we're going to set those equivalent to each other there, or ratio to each other. And we're still solving for the percent. So let's cross multiply these. And I get 32x equals 2,200. Divide by 32. Those cancel. Grab my calculator. And I'm going to say 2,200 divided by 32, and I get 68.75. And that's an honest answer for a percent. That's okay. So we have 68 3/4 of a percent that she has completed. All right, now let's look at C. Write the number of bracelets that Anna produced as a percent to those that Emily produced. So basically, if this was Emily to Anna, we're just going to flip those around. So now we have Anna to Emily. Oop, that's supposed to be a 2. Equals what percent? And always the 100 goes there. All right, so let's cross multiply. I get 22x this time equals 3,200. Divide by 22. Those cancel. And I come over here, 3,200 divided by 22. Oh, and I get this crazy decimal, but that's okay. So we're going to say x equals 145.45 repeating. If you notice, it's 454545, so that bar needs to go over both. Now, I also know that you can't write a repeat decimal as a percent, but I do know that 5/11 repeats that same pattern, okay? So what I'm going to do is say 145 5/11 of a percent. And there's your answer. Okay, let's look at exercise 1. There are 750 students in the 7th grade class and 625 students in the 8th grade class at Kent Middle School. What percent is the 7th grade class of the 8th grade class of the Kent Middle School? All right. So I do know that there are 750 7th graders, and I know that there are 625 8th graders. So since we're comparing it to 7th to 8th, that's how we're going to set that up. We are solving for percent because it says what percent, and we know our 100 is always there. So let's go ahead and cross multiply. I get 625x. And 750 times 100 is going to give me 75,000. All right, we're now going to divide out that 625. These cancel. Grab my calculator here. I'm going to say 75,000 divided by 625 is going to give me 120. So they make up 120%. And this makes sense because this number is larger than this number. So it's going to be over 100% because 100% would be 625 if they were 625 as well. That would be 100% one whole. But since it went over 625, that's how we get a larger percentage number. All right, now the question here says the principal will have to increase the number of 8th grade teachers next year if the 7th grade class enroll exceeds 110% of the current 8th grade enrollment. Will she need to increase the number of teachers? All right, so since there is 120% of 7th graders, as they move on next year, they're going to become 8th graders. So basically, this 120 is now going to be 8th grade students. So did it exceed the 110%? Yes. So we're going to say yes. She does need to increase the teacher population because there are 120% enrollment now. So 120% enrollment present. Which exceeds the 110% enrollment, basically. All right, there you go. Let's move on to the next one. At Kent Middle School, there are 104 students in the band and 80 students in the choir. What percent of students are in the choir is the number of students in the band? All right. So we're going to set this up as a proportion again with our line equals line over 100 setup. Now I want to know how many students are in the band to how many students are in the choir. So we're going to set it up 104 over 80. Now if they just flip those around, then you would flip these around. And we're solving for percent again. All right, so let's cross multiply. I get 80x. And 104 times 100 is going to give me 10,400. Divide out that 80. And again, you can do the zero rule here. Grab your calculator, and we have 1040 divided by 8, and I get 130. So the band exceeds the choir by 130%. At Kent Middle School, breakfast cost $1.25 and lunch cost $3.75. What percent of the cost of lunch is the cost of breakfast? So we're going to set up our comparison again here with line equals line, always over 100. So we're comparing the cost of lunch to the cost of breakfast. So we're going to go ahead and put $1.25 here, $3.75 here, and our X here. Now, how come I said it this way? I said it this way because it wants to know the percent of lunch. So the percent of lunch needs to be diagonal with the percent of lunch price, or the lunch price, I should say. All right, let's cross multiply here. I'm going to get 3.75x equals, now if you multiply these together, basically you're just moving the decimal 2 places out. So it gives me 125. I'm going to divide out the 3.75. These cancel, and over here I'm going to say 125 divided by 3.75 is going to give me 33.333 repeating. And in my class, we have learned that when 3 repeats like that, it is the fraction 1/3. All right. Okay, let's do our last one here. I'm actually just going to talk to you about it because I want you to come up with your own situation. So describe a real-world situation that could be modeled by using this setup here. Describe the elements of the equation, respond to the real-world question, solve your problem. All right, so what you want to look at is, how could I use these numbers into a real-world problem? Now, you could say 0.83. You can change that to 83%. All right, and then try and do something with this number. So that's all the little bit of help I'm going to give because I want you to be creative and try and think of something very cool. And everybody will have a different answer there. All right, that's the end of this training module, and I hope this video helped.